This demo will take us a step further with the Google Cloud platform. Not only are we going to implement our code in Data Lab, we are going to run it and train it in a distributed manner using Cloud ML Engine. In this section, we'll quickly introduce Data Lab and BigQuery. Data Lab, as you know, is the Python IDE or Jupyter Notebook run on the Google Cloud platform. And BigQuery is the data warehouse on the Google Cloud platform, which we can query using this SQL language. We'll build our machine learning model using one of the built-in estimators. We'll use linear regressor first and switch over to a DNN regressor to see if that improves our performance. So far, in all the machine learning prototypes that we've built, we manually build the model, then evaluate it on the validation data set, and then tweak the model. In production systems, this process of finding the best possible model is automated, and in TensorFlow, the experiment object allows us to build the model, evaluate it, and choose the best possible model based on our evaluations. We'll train the model that we build on the local machine just like we did before, but more importantly, we'll train it using Cloud ML Engine. This will allow us to distribute our training across workers in the cloud. Cloud ML Engine also offers a prediction service. You feed in the data that you want to use for prediction and get the result using an API or even using a command line. And finally, we'll discuss how you can perform hyperparameter tuning using Cloud MLE. You simply specify the hyperparameters that you want to tune, the range of values for each hyperparameter, and Cloud MLE does the rest. In this section, you'll learn something about the world of machine learning, which you'll only encounter once you've dealt with machine learning models in production. Now, at this point, you'll think if you had a lot of training data and a complex deep learning model, that would lead to great performance. But unfortunately, this is not true. You might need to add new features that you pass into your machine learning model using feature engineering. And you might find that feature engineering greatly improves the performance of your model. Once you've trained your model on the cloud, we'll go back and engineer our input features so that we can get much more out of the model that we have built. We'll get to feature engineering at the end of the section. By the time we get there, we would have actually built and trained and run a model on the Google Cloud using Cloud MLE. At this point, we'll see that despite large training data and despite the model being fairly complex, we still don't get good performance. The one thing that we know that we can tweak is to change how we pass the features in so that our model can learn more about the underlying data, which is where feature engineering comes in. Engineered features can be derived from existing features. We'll use cross columns where we'll specify two features which ought to be considered together. We'll use bucketized columns indicating that continuous values in those features are not important. Which bucket they are present in is more important. With these hints, you'll find that our model performs really well.